Welcome back to my YouTube channel Study with Stanley. Today we are in the second lecture of Structure of Atom lesson. In the last lesson we just studied about the basic structure of atom and the discovery of electron. In this today's session we will study about charge to mass ratio of electron and the charge of the electron. Without any delay, let's get into today's content. First, I will write the topic here. That is, today we are going to study about charge to mass ratio of electron. My dear friends, in the last lecture itself, I told you that electron is discovered by J.J. Thomson. He discovered electron in the year 1897. In that same year, he did another experiment. I'm writing it here. In the same 1897, he did another experiment from which he can able to determine the charge to mass ratio of electron. So my dear friends, he invented or he find out that cathode rays consist of electron using a cathode ray tube experiment that I already told you in the last lecture. With that same experimental setup, he said when electric and magnetic field are applied perpendicular to each other. I hope you can understand what does perpendicular means here. If they are applied perpendicular to each other, and also perpendicular to the path of electron. So my dear friends, in the last lecture when I teached you the characteristics of cathode rays, I told you that cathode rays always travel in a straight line. They have a mass and they have a velocity. They also have a kinetic energy. Those points that I teach to you in the characteristics of cathode rays. In that, I said you that they travel in a straight line. So when this experiment, that is the second experiment by J.J. Thomson done to determine the charge to mass ratio, he said when electric and magnetic field are applied perpendicular to each other and also to the perpendicular to the path of the electron, those cathode rays will deviate. So he said that the major conclusion is said from this experiment is the cathode rays will deviate from their original path. So my dear friends, just remember all these points. I'm writing it here. This experiment is done by J.J. Thomson, the same person who invented or who discovered the electron. So my dear friends, you may be getting some questions in your mind like how it will be possible. So that I will draw the experimental setup of this experiment so that you can easily understand it. Let me draw it here. My dear friends, this is the experimental setup made by J.J. Thomson. The same setup that he used for discovery of electron, but the change is that here this anode is perforator, which means it has some holes within it. The last lecture I told you the rays which travel from cathode to anode is called cathode rays. So when the voltage is applied to these electrodes, the cathode rays moves from cathode to anode, which is nothing but the negatively charged particle, that is electron, moving from cathode to anode. Through this perforation, they passes this anode and pass through this magnets and the electrodes. So this setup will produce the magnetic field and this will produce the electric field. So in this experiment, there is a principle that J.J. Thomson used. What are those principles means? I am writing it here. This extent of deflection is based on the factors that we call the first factor, the charge of this electron, and the second factor is mass of electron, and the third factor is the magnitude of electric and magnetic field. So my dear friends, by this experimental setup there are various principles. Those are that deflection of this wave is based upon the charge of electron, mass of electron, and the magnitude of electric and magnetic field. With this assumption, J.J. Thomson found that this rays pass through this magnetic and electric field and deflected into various directions. The last experiment or last lecture also I told you in a Crookes tube experiment, when a fluorescent zinc sulfide coating is given to the cathode rays, we can find the presence of cathode particles, which is nothing but the electrons, or the cathode rays presence will be easily detected. In the same manner, here also we have a fluorescent screen, so that when this particles or the cathode rays deflect and hit this fluorescent screen, we will get a spark of color so that we can find the presence of this cathode rays. In that manner, under various conditions, these waves deflect into three directions. The first one, the point A. This point is when only electric field is applied. This cathode rays will deviate and hit the point A. I am writing it here. This point, when the cathode rays deviate to this point A, that means only electric field is applied. Electric field is applied. And in the last experiment itself, we know that the cathode rays consist of negatively charged particles. How we find that? That is nothing but when electric field is applied, this electrons, which is negatively charged particle, deviate towards the positively charged electrode. That is the same thing happening here. This cathode rays just deviated towards the positively charged electrode. From that we can conclude here we have only electric field is applied. And in the point C, we can easily understand if electric field produce this deflection, then magnetic field produce the deflection, that is at point C. We can write it here. When the cathode rays hit at point C, we can find only magnetic field is applied. Then you may wondering, what does this point B means here? Here the point B means when electric and magnetic field are equally produced, or when there is no electric or magnetic field, this cathode rays will move in a straight line. That is the characteristics of the cathode rays. They always move in a straight line and they will hit at the point B. I will write that conclusion in a different color so that you won't get confused. They hit the point B when both fields are absent or equal in magnitude. So my dear friends, I hope you will definitely understand what does the experimental setup and the various process done by the J.J. Thomson. By all this experiment, he found that the charge to mass ratio to be as 1.758820 into 10 to the power 11 coulomb per kg. Let me write it here so that you can take a note of that. I will erase all these things. So after all those experiments, J.J. Thomson found that charge to mass ratio of electron is equal to be 1.758820 into 10 to the power 11 coulomb per kg. So my dear friends, this is in terms of kg. You can also write this value in terms of gram also. That is nothing, it's really an easy thing, you can do it yourself. So the most important thing here is, in the last lecture, the last part, I told you that electron is the basic constituent of all type of rays. Why? Because whenever that experiment, that is cathode ray tube experiment, is done with different gases or different type of electrode, the value won't change. In the same manner, when different gases and different electrodes are taken, still this electron to charge to mass ratio of electron is always remains same, that is nothing but 1.758820 into 10 power 11 coulomb per kg. My dear friends, put a star mark here. This value is very important because there are so many questions are asked continuously based on this charge to mass ratio. I am writing that conclusion also here, that charge to mass ratio remains same for various types of gases and different electrodes. So my dear friends, I hope you understand clearly about charge to mass ratio and how this value has been found out. So now we are moving to the second part of today's session, that is nothing but discovery of charge of this electron. Dear friends, this is the experimental setup used to determine the charge of the electron. So this charge of the electron has been determined by R.A. Millikan. During the year 1906 to 1914, he made various experiments and found out the charge of this electron. So this is the experimental setup. Let me explain this. Here we have an atomizer which is containing oils. When we pump this oil inside this chamber, this oil will convert it into a minute drops. Through this electrode, which is positively charged, which is having a small hole, only one drop is allowed to fall inside this middle chamber. This middle chamber will allow X-rays to pass into it. When X-rays pass through this middle chamber, the gas molecules which is already present inside of this will get ionized, so that this electron will attach towards the outer surface of this oil drops. With the telescope, he can find that how many charges are or how many electrons which are present inside of the or attached towards this oil droplet, and he found that the smallest charge which is attached towards this oil particle is nothing but 1.60 into 10 to the power minus 19 coulomb. This is nothing but the charge of electron. This is nothing but the charge of electron. So my dear friends, this charge is in the, and he also found that charged particles or the charges around this oil droplets are in the form of Q is equal to Ne, which tells that the charge is quantized, which means one charge or two charge will be attached, but not 1.5 or 2.5 charges will attach to this oil drops. So my dear friends, with this experimental setup, he found the important value that is nothing but, I'm writing it here, found that 1.022 into 10 to the power minus 19 as the charge of coulomb. So this charge having a negative sign in front of this value, which tells that electron is negatively charged particle, so that this also have a negative sign before it. So my dear friends, I hope you now understand what does this oil drop experiment tells to you. So since Millikan found the charge, we named this experimental setup as Millikan oil drop experiment. So now we are moving to the second part of this Millikan experiment, that is the determination of mass of electron. Let me erase all these things so that you can understand it clearly. So in the previous session, I told you that charge to mass ratio of electron is nothing but 1.758820 into 10 to the power 11 coulomb per kg. And from Millikan oil drop experiment, we found that charge of electron is equal to 1.6022 into 10 to the power minus 19 coulomb. So my dear friends, can I divide both these things so that I can get the value of mass? Yes, absolutely you can do that. If I do that division, I'm writing it here. So this is the first value we got, and this is the second value we got. I'm just dividing 2 by 1. It is nothing but E divided by E by M, mass of electron. So I'm writing that value here. We are taking the magnitude of charge 1.6022 into 10 to the power minus 19 coulomb divided by 1.758820 into 10 to the power 11 coulomb per kg. So my dear friends, when this charge get cancelled, we will get the value of mass of electron. That is, we found out the value of mass of electron to be equal to 9.10939 into 10 to the power minus 31 kg. This is very important value. Just put a star mark over it so that you won't forget it at any cost. So my dear friends, you may be wondering how this value gets cancelled. That is an easy calculation. You can do it with yourself. So that I am writing that direct answer, that is nothing but mass of electron is equal to 9.10939 into 10 to the power minus 31 kg. So my dear friends, this is the direct value. But in exams, they are using various other units. So you should also know the mass of electron in the various other units. Don't worry, I will explain that also. So I will erase all these things so that we can move to this next session. So now you know mass of electron in terms of kg as 9.10939 into 10 to the power minus 31 kg. This is the mass of electron in terms of kg. So they also ask that mass of electron in terms of mass of hydrogen atom. That's nothing but mass of electron is equal to 1 divided by 1837 into mass of hydrogen atom. So this is very important. There are so many previous questions containing the direct question, which is nothing but what is the ratio of mass of electron to the mass of hydrogen atom, which is nothing but 1 divided by 1837. In terms of atomic mass units, that is AMU, mass of electron is equal to 0.00054 AMU. So this AMU means atomic mass unit. I hope you know that. So these are the three values that you should just remember directly so that you can answer all the questions. So I'm just highlighting it with another color so that you won't forget it at any cost. I'm also putting a star mark here. This is very important. This is very important because you may get direct questions from this value. So my dear friends, today we just learned about charge to mass ratio of electron, charge of electron, and also the mass of electron. I hope this session is really useful to you. If this is useful to you, share this video with your friends also. And don't forget to subscribe my channel. Thank you. Have a nice day.